Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 12 mathematics functions and inverses. So, today we are looking at linear functions and their inverses. So, let's begin this by reminding you what linear functions are. Remember, you can also say linear graphs, whichever you prefer. So, remember, y they have the formula y equals mx plus c, all right? Where, if you remember, this m represents the gradient, all right? This m represents the gradient, which is also a slope. And you recall, to find this gradient, you use the formula y equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Or you can use the angle of inclination, where you say the gradient is equal to tan theta, where theta is the angle of inclination between your graph and the x-axis, right? Now, you also remember, this is from grade 10, right, guys? In fact, grade 9, that when your gradient is positive, your slope or your line is like this. And when your gradient is negative, your line is like this, meaning it's a decreasing line. When your gradient is positive, it's an increasing line. When it's negative, it's a decreasing line. All right? And again, this C is the y-intercept. Y-intercept is where the graph cuts the x-axis, right? Y-intercept is where the graph cuts the x-axis. Maybe let me write that. So this, you are in grade 10, I know. Grade 12, sorry, the graph cuts, where the graph cuts the y-axis, right? Where the graph cuts the y-axis, right? This is your y-intercept. Okay, so these are the things that we remember from grade 9. 10 again. Now let's look at the domain and range. So the domain of your straight line graph has always been x is an element of real numbers. Now with the domain, you remember we said it is set of input values. All right, set of input values. Sorry, set of input values. Okay, so for a straight line graph of a linear function, all x values are valid, meaning all x values will return a y value or a corresponding y value. Now let's look at the range. Now the range, now let me write going down next, right? The range, when we look at the range, it allows for a linear graph. Any y value you can think of here will give you an x value, right? Any y value will give you an x value. So when we talk of a range, we're talking of set of output values. Okay, we're talking of set of output values. Okay, set of output values. So here we're looking at y values from the bottom to the top, the lowest y value to the highest y value. The domain, the lowest x value, meaning the most negative to the most positive. Okay, so this is all that you need to know regarding your straight line graph. So otherwise your linear function. So let's have an example. Let's have an example. So an example, I'm gonna say sketch the graph of f of x equals 2x plus 4. Already you know the y-intercept. Let's begin by finding the x-intercept. Okay, let's begin by finding the x-intercept. Okay, let's begin by finding the x-intercept. So remember, when we want the x-intercept, we are saying y will be equal to 0. What is our y? It is 2x plus 4. It will be equal to 0, right? So we have 2x equals negative 4. Therefore, x is equal to negative 2. Our x-intercept is 2 and 0. Now, let's plot. So when we plot, let me change the grid, increase it a bit. I want to make this grid. Let me, yeah. Okay. Okay, thank you. So, thank you, buddy. So we have this. Let's try this. And then we have this. Let's try this. Okay. We have 1, 2, 3, 4. Okay. So we have 1, 2. Oops, it won't work. Let me move this one down. Okay, let me move this one. Okay, let me move it a bit. Okay, think it works now. 1, 2, 3, 4. That's fine. And then 1, 2, 3, 4. That's also fine. You are 0, buddy. 1, 2, 3. Okay. 1, 2, 3, 4, 5. Negative, negative, negative. That's good. This is x. This is y. Okay. So we said y-intercept was 4, x-intercept was negative 2. Right? Y-intercept was 4, x-intercept was negative 2. So let me join the point. Mm-hmm. 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 Let me see. Yeah. Oh yeah. Perfect. So this is your um f of x. Do you see this? This is your f of x. Let me just put these arrows to say it is extending. Now I can remove the grid. Oh, let me not remove the grid as yet. Okay. So this is your no, I can remove it. Let me remove it. I don't like working with the grid. Okay, so this is your f of x. Do you see? We drew it. All right. This is your f of x. We drew it. All right. Perfect. Now, as you can see, we said the domain is always x is an element of real numbers and the range y is always an element of real numbers. Guys, this is always. So we were able to sketch this. Let me indicate some points here. I'm going to use a different color. So this point here is negative 2 and 0, whereas this point here is 0 and positive 4. Okay. Now let's head to determining the determining the determining the inverse. Let's call the segment here determining the inverse. So an inverse, which we're going to call f to the negative 1 of x, right? So f inverse, if you like. An inverse is a reflection on the line y equals x. Is a reflection on the line. It's a reflection on the line y equals x. Okay, so this means from whatever that you know, okay, from whatever that you know, what was x becomes y, what was y becomes x. So you don't even, for example, you are given an original here. So what you will need to do is this. I'm going to use a different color. So let's begin by plotting. This is negative 2 and 0. This means it's going to be 0 and negative 2. That's 1 point. This is positive 4 and 0. All right, this is another 0 and 4. So it's inverse. What was y becomes x, what was x becomes y. So this will then become 4 and 0. Here is it. So our inverse will be passing here. Without even any waste of time, let me now join this line. It'll be like this before. And then Okay. Mhm. So what is this? You see, without even knowing what the equation is, I am able to draw the inverse. All right, I am able to draw the inverse. Do you see, guys? Without knowing what the inverse is, the equation of the inverse is, I am able to draw the inverse. Now, I'm gonna determine the inverse. Let's go now. Remember, this is the inverse. Now, our example, oops. Now, example, determine and sketch, okay, determine the inverse of, let's use that one, f of x equals 2x plus 4, and also draw it. And also sketch it. Okay. So for our solution, let me go to the next page. Our solution, so our solution, remember we had f of x, which is y, is equal to 2x plus 4. So I like writing this reflecting on y equals x colon. This is an instruction. What was x becomes y, what was y becomes x. Let's see. X equals 2y plus 4. Now we will make y subject of the formula. This will become x minus 4 equals 2y. Dividing throughout by 2, we have half x minus 2 equals y. What does it mean? This means f inverse of x is half x minus 2. Okay? Half x minus 2. Now, this is the equation of the inverse. As you can see, y-intercept is 0 and negative 2. Did you guys see that? So, y-intercept, it's 0 and negative 2. Why? Because the constant is negative 2. Now let's look for the x-intercept. For the x-intercept, remember for a straight line, we don't have to stress if the constant is given, we just use that constant. Now we will say this means f inverse of x equals 0. What is this? Half x minus 2 equals 0. So what is this? Half x equals 2. Multiplying throughout by 2, we will get, or if you don't want to say multiplying throughout by 2, you can say dividing throughout by half. It's the same thing, guys. On your calculator, if you display 2 divided by half, you will get this following answer. X equals 4. Therefore, our x-intercept is 4 and 0. Guys, remember, x-intercept is 4 and 0, y-intercept is 0 and negative 2. Let's go check out if indeed this was the inverse. X-intercept was 4 and 0, but y-intercept was 0 and negative 2. Isn't this what we got? It is indeed what we got, right? It is indeed what we got. So you see, I was able to draw the inverse given the original. I was able to draw the inverse without even knowing what the equation of the inverse is. Okay, so let's repeat here. The inverse is, sorry, the original was, let me begin at this one. This is half x minus 2, and then the original was 2x plus 4. Do you guys see this? Now, there's a summary that I want to make from this. Okay, there's a summary I want to make from this. Let me perhaps delete this guy for a moment. Let me delete this guy for a moment. So, yep. Yeah, yeah. I'm gonna say copy to current, but I know I just want to cut you. Okay. So what I want to do now is I want to make a summary. All right. I want to make a summary. So this we were able to sketch. All right. Now let's make a summary. Okay. Let's make a summary now. I'm going to make a summary. And this summary, let's see. I'm going to paste you, buddy. But I'm going to reduce you. Okay. There we go. Are you fine now? Yep. Okay, so this summary, I want us to do this. I want us to look at the x-intercept. Okay, I want us to look at the x-intercept, then look at the y-intercept, then look at the gradient. Okay, then look at the gradient. See that up that guys? Then look at the gradient. Ooh. Then look at the gradient. Okay, then for the original. Okay, for the original. And then for the inverse. Okay, so let's do this. Uh-huh. Uh-huh. Mm-hmm. Mm-hmm. So for the original, what was the x-intercept? Look at it. It was -2 and 0. And then what was the x-intercept for the inverse? It was +4 and 0. The y-intercept for the original was 0 and 4. And for the y-intercept, for the inverse rather, it was 0 and -2. The gradient is 2, and for the inverse, it is half. Do you guys see this? So when we generalize this, I want you guys to see this. So when we generalize this, look at this. What was the x-intercept? It's -2 and 0. When it changes, when you reflect it on the line y equals x, it becomes the y-intercept. So what we say, generally, x-intercept becomes y-intercept. It doesn't matter of what, guys. Whichever you're given, its inverse. What was the x-intercept? Its inverse. For its inverse, it'll be y-intercept. Now check. What is the y-intercept? Do you see this? What is the y-intercept? What does it become? It becomes x-intercept in the inverse. Right? Now, look at the gradients. You don't have to put this x. You don't have to put this x. It's just half. Look at the gradients. For the gradients, what do you have? For the gradients, 1 is 2, the other is half. So what is this? It is the inverse. So gradient of one is the inverse of the other. Right? So our product, let's just say product of gradients is 1. Product of gradients is 1. Product of gradients is 1. Meaning gradient 1 times gradient 2 will be equal to +1. I remember with perpendicular lines, you said they are equal to -1. Do not confuse that. Okay. So here what I'm saying is that gradient of one is the positive inverse of the other. Okay. So guys, this is your linear functions and their inverses. I'm not talking of their domain and ranges because they are always y is an element of real numbers. X is an element of real numbers. Domain, X is an element of real numbers. Range, Y is an element of real numbers. It does not change. That is how you look at your linear functions and their inverses, of course. So this is a summary that you need. So with that being said, we have come to the end of our session. So remember to get in touch with us by visiting our website, ramtasolutions.co.za, or in the description of this video, you will see a link to all these icons, to all these social media platforms. Okay, you can follow us even on WhatsApp. We have introduced a WhatsApp channel. You can follow us there. We will update you of your whatever that we might be updating on our website and even on YouTube. Okay. So, with that being said, because you are watching on YouTube, please like if this video was helpful for you. And of course, if you would like to keep in touch with us by following us, you can also subscribe and become a member of the family. So, with that being said, ours ends here and all the best. Bye bye.